Hello everyone, welcome to the live class. So guys, today we are having another very important session. That's gonna be our nuclear and elementary particle physics session. We are going to consider some of the very important concepts based questions in today's session. I hope that the discussion which we are going to do in this session will be helpful for all of you to prepare important concepts and to know about them. So let me know once in the comments that is everything all right, audio, video, slides, everything fine. I'm just going to check your comments here and then we will continue the discussion. So please let me know once and then we are just going to continue this discussion then. That's very good, very good, very good. Okay, all clear, all good. Everything all right? Yeah, that's good. So guys, I will take some time to let you know about the Unacademy Plus subscription and some of the important points, and after that we are just quickly going to start the question discussion from the nuclear and elementary particle physics part. Okay, so let me just tell you about it first. So basically guys, as you all know about the Unacademy Plus subscription and the benefits you can get from the after taking the Unacademy Plus subscription, let me just tell you about it once. So basically guys, on Unacademy Plus we are going to have so many important courses which are going on, like the quick revision course, the practice course, and many other courses by all the top educators. So if you want to attend the live classes of all these important courses, then you can take the Unacademy Plus subscription. Even in upcoming days, there are going to be the courses which will start for the GATE physics exam preparation as well. Okay, so yeah, even if you are going to take the subscription right now, you will be able to attend all these important courses and their sessions. One more thing, if any course is already going on and you are taking the subscription right now when some of the sessions of any course has been conducted, okay, so in that case you will be able to cover up that portion too with the help of recordings, because you will have the recordings available to you. Also guys, by using and by applying this referral code, that is Anjali Arora, as it is mentioned here, you can get the 10% discount in the total Unacademy Plus subscription amount. No space in between, spelling should be same. That's how you need to write it and apply it to get the 10% discount in the total Unacademy Plus subscription amount. Okay, and all these important courses, their classes by all the top educators, you will be able to attend. Okay, and that's how all these things together will help you a lot to prepare very well for your upcoming exam. So whenever you are going to take the Unacademy Plus subscription, you can use and apply the referral code Anjali Arora as it is mentioned here, and you will get the 10% discount with this one, okay, in the total Unacademy Plus subscription amount. Also in the description of this video, there will be the link as well. Okay, you can just click on that and you can proceed further. You can check out the sessions and the courses. Also guys, if I'm going to talk about the next thing, you can even use the referral code, that is AnjaliALive, as it is mentioned here. By using and by applying this referral code as well, you will get the 10% discount in the total Unacademy Plus subscription amount. But at a time, you can use any one, either Anjali Arora or AnjaliALive. Any one of the referral codes you will use and apply. If I'm going to talk about another important thing, so guys, there we are going to have the championship mock test as well. So on Sunday you are going to have the championship mock test, and on Monday we are going to have its analysis session. Like in the upcoming days in that same week, you can have the analysis session. So if you are not participating in the championship mock test, you can do that. It will be helpful for all of you to get familiar with the online exam pattern and to know about all the important things. Okay, that how you should manage your time, how you will attempt the questions in the exam, and many things. In many ways, it will even be helpful for you. Another thing is, we are going to have the Revise India series going on Unacademy Plus, okay, or on Unacademy Learning app. These are the special classes, as after this class today, I'm going to conduct a session in the Revise India series. That's gonna be about the atomic and molecular physics as well as for thermodynamics. So for these two subjects, we are going to have the session today in Revise India series at 1 o'clock. Okay, after this class, you can attend that session too. One more thing guys, let's say you have not attended any session in this Revise India series which I have conducted. So don't don't worry, for this session which is there today on 13th November, it will be named as day 13, Revise India series day 13. In the description of this video, you will get the link for the special classes or for the free live classes. You will check it out and it's gonna be there. Click on that. You can check out the previous sessions as well as this one. So if you have not watched those sessions, you can check them out and you can watch them. So don't miss, there is gonna be some very important discussion. I hope each and every point which I have discussed till now will be clear to all of you. And now we are going to start the discussion about the nuclear and elementary particle physics questions. Done? Done. That's very good. Everyone, like every one of you, ready for the discussion? Can we start the discussion then? That's very good, Subramanyam. Soon you are going to have more such, okay, questions and their explanation and answer, like everything. So, okay guys, can I give you the first question then? Are you all ready for the questions and for solving them? I hope yes. And if yes, that's very good. Let's just start the discussion with our first question. And guys, even if you have not prepared this subject, yes, yet you are still having a chance. You are still having time to know about it and to prepare it. Okay, so don't miss this opportunity. Even along with the questions, if we are using some formula which you don't know, okay, till now you are not having any idea about it, but now when you are observing it, you are observing the question statement, the parameter given and everything, clear? So in that case, you should try to learn this thing from the questions ki, oh, if this is gonna be the type of question, this is the formula I will use and apply, and that's how I'm going to get the answer. So everything is gonna be important one. Okay, have a look at the first question I'm going to give you now. It's gonna be important one from the shell model part. Okay, so also it is a previous year question from CSIR net physics exam. It's here. According to the shell model, according to the nuclear magnetic moment, the nuclear magnetic moment of the aluminium nucleus is given that for a proton, it's here, given that for a proton GL is equal to 1, GL is equal to 1, GS is equal to 5.586. This data is already given in the question. 5.586. Done. And for a neutron, GL is equal to 0 and GS is equal to minus 3.826. Clear? This data is given to you here. Now the options are, you all can start solving it. And if you don't know the approach or the formula or the steps you have to consider, don't worry, I will let you know. Minus 1.913 mu n, where mu n will be the nuclear magneton, okay? And it is not mentioned in the question directly. It is just given in the options like this. mu n 414, right? Option C is 4.793 mu n. Option D is 0. So start solving it and let me know as you are going to get the answer. And if you will have any doubt or difficulty anywhere, I will talk about it. I will let you know the formula, the steps, and every important thing. Okay, so don't worry about that. Sahil? Okay, let's talk about that thing. Just a second. Guys, basically, see, it completely depends on the type of question paper you will have. The type of questions will be there, okay, completely on all those vectors and parameters. So even after the exam, it's gonna be the estimate cutoff. Anybody can tell you the approximate one, the idea only. Done. So exact cutoff, without knowing about the paper, without just getting to know about the type of questions there, okay, like nobody will be able to tell you the exact one. But for the safe side, what you should do, I would say target for more than 120 marks, okay, more than that. So you will be in the safe zone. So instead of thinking it's gonna be 70, it's gonna be 80, it's gonna be 100, try your best, whatever then you will be able to perform, like how you will perform in the exam, how many number of questions you are able to solve there. Just give your best, okay? And if you are targeting for 120 plus marks, you will be in the safe zone, because you will even be able to do more than the required marks questions, okay? So it will be always better, but try and give your best. Done. That's what is required. Very good, the beast. Very good, Neetu. What about others, guys? Let's wait for everyone's reply once and then I'm going to start the discussion. Here is the complete question and here it is gonna be like this. Okay, I'm just going to wait for everyone's reply in the comments once and we'll soon start the discussion. Excuse me. Very good, Kaku. Okay, Nandini, we will try to consider that also. Even if you will check my previous sessions I've conducted on mathematical physics, I think you will be able to get it in some of the sessions. Okay, so you can check that too. Very good, Jyoti. What about others, guys? Till now, four students have replied or answered for this question. Very good, Shabnam. This is basically J. Excuse me. Because whatever is odd, the nucleon which is odd, okay, that will contribute or that will help you to get the value of J, that is angular momentum. Now when you want to find the mu, what its value will be, let me just tell you about that. It's gonna be mu is equal to half 2j minus 1 plus gs into mu n. Mu n again is nuclear megnatone. So depending on this thing, you will be able to get your final answer. As all the parameters are given in the question, just put the value and try it now. I hope you will be able to get it right. Okay, and the configuration which you will write, the sequence, that should be as per the shell model, okay, for 13. And the J value which you must be getting, that will be 5 by 2 and L is equal to 2. J will be 5 by 2 and L is equal to 2 there. So this is gonna be the case. Here L is equal to 2 and J is equal to 5 by 2. So then you can use this formula. Done? That's how you are going to get it. Just try it now and I hope you all will be able to get the answer. That's very good, everyone. Right. Okay, for any such question, this is gonna be the way how you will get the answer or what are the steps you will take. And once you are going to solve it in this way, your answer will match with option C. Clear? So focus on the steps, even the formula. If you were not familiar with it earlier, now you should get to know about it. Okay. Saddam, mu n is gonna be nuclear magnetone. You don't need to put its value here. It's just given like that, mu n. So don't put its value. Keep it as it is. Done. And there is a relation between the mu n and mu b. Okay, I think it's 1/1836 times. Like you can just check it out, but they both are related. So even if you are familiar with mu b, that is Bohr's magnetone, they both are related. It will be easy for you to memorize its value as well if you know about the mu b. Clear? So guys, can I give you the next question now? If this one is clear. Ready for the next one? Okay. So the steps which you have to consider for the nuclear magnetone are gonna be these ones. Whatever is odd, firstly find the J value from there. Okay. And whatever is even, that will not contribute in finding the J value, and just use the formula and get your answer. Let's talk about the next one now. Next question is gonna be related to quarks. Okay. So the question is, a particle which is a composite state, a particle which is a composite state of 3 quarks U, D and S, of 3 quarks U, D and S has electric charge, spin and strangeness respectively. Electric charge, spin, and there is a difference between isospin and spin. Okay, so be careful about it, that what is mentioned in the question. Strangeness respectively. It was off here. Options are one half minus 1, 0, 0 minus 1, 0 half minus 1, minus 1 half 1. Try it now, and whatever option is correct according to you, you can mention it in the comments. Shankar, not required. I have directly told you the expression after putting the values. Okay, GL was there, but right now it was not required because I have put its value there. And if you want to know about the main formula, I will provide you. Clear? Where the GL will be mentioned. Very good, Neetu. Very good, the beast. Let's wait for this reply too, and then we are going to talk about it if required. If it will be clear to all of you guys, that's very good. Very good, Subramanyam. Hello, Prince. Okay, Shankar. Very good, Kaku. Very good, Shabnam. Very good, Saicom. Very good, Prince. Very good, all physics concepts. That's good, good, good. Is this clear to all of you, or is there anyone who is not getting this question or don't know about the process or the steps to solve it? Is there anyone who is not familiar with the steps you have to take or the things you need to know about it? Very good, Saddam. Very good, Shivam. Everyone knows about it and getting the answer option C, which is correct. If you are getting option C, that's correct. If you are not getting it, you can tell me. Very good, Monalisa. Okay, Kuldeep. Kuldeep, so I will tell you one thing here which will help you to prepare any such type of question. Okay. Shankar, yes, it can be 3 by 2. There is a particle omega. If you will check it in the baryons, omega is having the spin 3 by 2. Okay, so yeah, 3 by 2 can be the spin. Look at this. Those who don't know about it, guys, for them, there is little bit discussion about the quarks right now we will do. So let's consider it in this way. See, there are going to be total how many quarks? 6, which we will consider. So up, down, strange, charming, okay, like that. Top, bottom. Clear? These are the different quarks we are going to have. Now, their properties. Always remember these quarks are going to have only 2 possible charges. Plus 2 by 3 or minus 1 by 3. Only 2 possibilities are there. Either plus 2 by 3 or minus 1 by 3. But how to memorize it? Let's talk about that. We already know up means what? Up means positive. Okay? So positive means the up charge, the up quark will have a charge plus 2 by 3. I have told you there are only 2 possibilities. Either 2 by 3 or minus 1 by 3. Look at this. Down, negative. Okay, let's write it later on. Now let me know, strange or charm? Something is strange. Okay, something is so charming. Which one should be positive according to you? Charming or the strange one? Which one should be the positive one? कुछ अगर बहुत चार्मिंग है दैट मीन्स वो उसका एक पॉजिटिव एस्पेक्ट बोल सकते हैं, ठीक है. तो दैट्स वाई व्हाट वी विल डू, वी आर गोइंग टू कंसीडर इट्स चार्ज प्लस 2 by 3. अगेन टॉप पॉजिटिव 2 by 3, bottom negative. So rest of them like the down minus 1 by 3, strange minus 1 by 3, bottom minus 1 by 3. In this way you will not have to put so much efforts, okay, to memorize it, and easily you will be able to memorize it in this manner along with just making this table. Okay, then let's talk about the next thing, that is the baryon number. If I'm going to talk about the baryon number for all these quarks, the baryon number is 1 by 3. So 1 by 3, 1 by 3, 1 by 3, it's so easy. Done. If I'm going to talk about the next thing, that's gonna be isospin. Only first two are going to have the isospin, that means up and down, which is half, half. That's it. All other 0, 0, 0, 0, 0. Next one, I3. That is the Z component or third component of isospin. Excuse me. So only up, because we know Z component of isospin or third component of isospin is going to have different signs as per the charge state present there. So again, up positive plus 1 by 2 and down negative minus 1 by 2, I3. Rest 0, 0, 0, 0. Next one, that is the strangeness number. Only strange quark will have the strangeness number, and that's minus 1. So you can easily memorize it like, okay, only this one. Others 0, 0, 0, 0. No strangeness. Like, next, hypercharge. You can easily write it. Y is equal to B plus S. Just add the values. The baryon number you know, strangeness number you know, just add them. You will be able to get it. Next is spin. Spin. It's not 1, okay? It's just any value, whatever you will get here after adding. Next one, spin is half for all of them. These are the properties or characteristics related to quarks. Okay, basically their values for different parameters which you all should know, and once you are getting familiar with these properties, you are getting ready to solve most of the questions related to quarks. It's very important. Okay, and in some or in other way they can ask you the questions based on let's say quarks. Okay, किसी भी तरह से पूछा जा सकता है, so it's important part. Physics paradox, it's gonna be 15 to 20 marks approx. Okay, but the point is, since it is in part C, so questions are gonna be in 5 marks and they are going to be sometimes quite easy. कई बार बहुत easy होते हैं, तो अगर आपको पता होगा ना, तो आप ऐसे ही उनके आंसर फाइंड कर पाएंगे जल्दी से. Is that clear to everyone? Can we talk about the next point? And you can see how I've made the table. I was not just making it, I was also letting you know how to keep it in mind that what is going to be the particular value for charge, strangeness number and anything. So now you are even ready to make it. Try it after the session once again and try to write all these values. It will be helpful for you. Done? Let's talk about the next question now. And in this way, okay, let's talk about this question first. In this way, how you will be able to get the answer for this one. Look at this. A particle which is a composite state of 3 quarks U, D and S, up, down and strange, okay, has electric charge. We need to find its electric charge. So we know for up quark, what is the charge on up quark? That's gonna be 2 by 3. What about down? That's gonna be minus 1 by 3. What about strange? Minus 1 by 3. So 2 by 3 minus 2 by 3 will be what? 0. Where 0 is present? Option C and option B, both the places. What we need to check next? Spin. 1 by 2, 1 by 2, 1 by 2 spin for U, D and S. Okay, 3 by 2. But sometimes if in the options 3 by 2 is not present, you can select 1 upon 2 there. Okay, that's okay. But 0 will not be okay in this case. So you will select 1 upon 2, which is in option C. And since the third one is same in both the options, so we don't need to worry about it. It's going to be your right answer. That is option C. Okay, that's how, if you know the properties, by knowing the properties and by simplifying it in this manner, you can get your right answer quickly and in less time. Okay, so you can see how important these values are. Let's talk about the next question now. Clear? Next one. If in a spontaneous, now it's gonna be related to alpha decay. If in a spontaneous alpha decay of 232 uranium 92 at rest, the total energy, okay, the total energy released in the reaction is Q, then the energy carried by the alpha particle is. Options are 57 Q by 58, q upon 57, q upon 58, 23q upon 58. Try it now and let me know as you are going to get the answer. If you don't know about it, I will let you know. Then don't worry. Done? Just try it now. And whatever option is correct according to you, you can mention it. We will just talk about that one. Very good, Saicom. Very good, Prince. Very good, The Beast. Very good, Arna. Very good, Prince. Very good, Kaku. Very good, Nazia. Very good, Basha. Very good, Shankar. Very good, Wafia. Okay, very good, Sam. Very good, Hiram. Okay, that's good. Very good, everyone. But if there is someone like who don't know about the process, who don't know about the steps which you have to consider here, let me just tell you about it. So if we are going to talk about the energy carried by the alpha particle, okay, what is going to be the formula for that thing? Let me just tell you about that first. The energy carried by the alpha particle will be A minus 4 upon A cube. Okay, that is the energy carried by the alpha particle here, which you need to find. Now the point is, let's just go through the question, and this is corresponding to alpha decay. Okay, if in a spontaneous alpha decay of this uranium at rest, the total energy released, okay, if in a spontaneous alpha decay of uranium at rest, the total energy released in the reaction is Q. Okay, this is the energy released. So that is present here in the formula as well. Now, then the energy carried by the alpha particle is, what will be the kinetic energy basically they are asking for? Because the alpha particle energy, here we are showing it with E. Okay, so anytime related to alpha decay, if you want to find it, you can use this formula. Now the point is, what is A value in the given nucleus, corresponding to given nucleus? What is the value of A? That's gonna be 232. You can put it here. Okay, and 232 minus 4 upon 232 into Q, you will see that the answer which you will get after putting that value, that will be same as option A. Hence option A will be the correct option. You can just try it after doing the calculation, and after putting the value of A, you will get the same answer. Okay, that's very good. Very good, Kunjan. Very good, Neetu. Very good, Ithan. Very good, Jyoti. Very good, DN. Very good, Abhishek. That's very good, everyone. I hope it will be clear. And from the alpha decay topic, this is one of the important formulae. Okay, and you can expect the questions based on it again in your upcoming exam too. So let's talk about the next one now. Clear? Very good, Neha. That's good. And also guys, if anybody is here who was not familiar with the formula, please note it down and memorize it. It's gonna be important and you can expect it in your upcoming exam too. So this is the energy carried by the alpha particle in the alpha decay process, which will be A minus 4 upon A into Q. Next question. Very good, Basha. Very good, Ramesh. That's very good, everyone. Next question is here. Again, from one of the very important concepts. The spin parity. Assignments for the ground. Assignment for the ground state, for the ground state of (28) Okay, as per the shell model is, so here are going to be the options. 1/2 negative, 5/2 positive, 3/2 negative, and 3/2 positive. Check it now and let me know once you will get it done that whatever option is correct according to you. Very good, Abhishek. We will talk about it. Very good, the beast. Very good, Neetu. Very good. Hiram, very good, Kunchan. Very good, Karishma. Very good, all physics concepts. Very good, Prince. Very good, Jahir. Very good, Mitali. That's very good, everyone. But there are two different answers I've got. Like one is option B, another one is option C. Okay. So here we are going to have very good, Vasudevan. Very good, Arif. Very good, Subramanyam. Very good, Kaku. Clear? If we are going to talk about the process, anybody is having any doubt in this question, or is this clear to everyone? Very good, Wafia. Very good, Arif. Very good, Saikom. Very good, Neha. Very good, everyone. Just a second. Yep. Okay. That's good. Arundhati, there is some doubt. Okay. So first of all, what you need to do, since here we are going to have the number of protons. What is number of protons here? That's gonna be 28. Okay, 28 number of protons, which means Z value. Now what will be number of neutrons? Total mass number 57. So number of neutrons will be 57 minus 28. What you will get from here? That's gonna be 9, and from here you will be able to get are you getting 28 was already there now? One second. It's gonna be 29. Are you getting it exactly same? Just check it once and let me know if it is exactly same or something else. Now the point is, you just need to consider whatever is even or whatever is odd, you have to look or just observe that part first. If you are going to consider that part, you can have a look at this 28, which means the number of protons. It's gonna be even in number. Okay, even means they are not going to contribute to the spin and parity part. Clear? And you just don't need to write anything for this one. But whatever is odd, you have to consider it and you have to write the configuration corresponding to that. Clear? So for 29, as per the shell model, you will write or mention the sequence for 29 nucleons, which are neutrons here. Okay. So as per the shell model, if we are going to write the sequence, so what are the values you will get? First of all, you need to know that. Till 28, since we are going to write it here right now, it will get clear to you. But if you don't know about rest of the points, if possible, you should try to consider that too. It's gonna be 1s half, okay, 2 nucleons in this one, which is neutron in this case. After this, it's gonna be 1p 3/2, which is again, it's gonna have 4 here, done, 4 to 6, but you have to write it till 29, okay. So 1p 1/2, which means again 2. And if anybody is here who is not sure about the sequence, guys, prepare it. It will be good for you and will help you to solve more questions. Clear? Next, after 1p 1/2, you will have 1d 5/2. 1d 5/2. How many nucleons in this one? Total 6. Okay, and how you are getting to know about it? This is the value of J, half. So 2 into half plus 1. What is that? That is 2. So maximum 2 can be here. That's how we are deciding, or we know that how many maximum number of nucleons can be there. After this, 2 is half and 2. Okay, you have to write it till 29 here. After this, 1d 3 by 2 and 4. 1d 3 by 2 and 4 will be there. After this one, 1f 7 by 2 and 8. Clear? Then the last one is 2p 3 by 2 and 1. 2p 3 by 2 and 1. That's it. Let's count it. Whether we have mentioned it till 29, everything is here or not. Or did we leave any of the term? So have a look at this. 4 to 6, 7, 8, 8 and 6. Again, you are going to have 14, 14, 15, 16, 16, 4, 20, 28 and 1, 29. So it's done. Now what you need to do, corresponding to the odd nucleon, you just need to consider the last unpaired one. Okay, the last one. So here the last one is 2p 3 by 2. What is the value of J corresponding to that? 3 by 2. If you know this sequence, this is like a fixed sequence. Okay, as per shell model, you just need to prepare it. And then for any such type of question in which you need to find the spin and parity, you have to consider the same process as we are considering it right now. So the last unpaired electron nucleon here, it is present corresponding to J is equal to 3 by 2. Write it here. J is equal to 3 by 2. But what about parity? Basically, we are trying to find JP value. Here the parity should be present. So the parity formula is minus 1 to the power L. Clear? What is this orbital? P orbital. So for SPDF, SPDF, if you want to know about the values of L, they are going to be 0, 1, 2 and 3 like this. So for P orbital, it's 1. L is equal to what? 1. So write it here, minus 1 to the power 1, which will be minus 1 only. So the parity here is minus. So 3 by 2 negative is the right answer. And guys, such type of questions you can easily prepare in the GATE physics exam, in CSIR net physics exam. In both the exams, these are like the most frequently asked questions. Okay, so yeah, right answer will be option C. Is this clear to everyone? And guys, one more thing. Let's say you are attending this session right now and you have not prepared this topic yet, but you got the idea that okay, this is something I need to do. This is how I will take the steps and how I can get the answer. Done. One more thing. So what you can do, since here I have mentioned the sequence till 29, if you want to prepare it till 30, till 35, till 50, so just prepare it, because the process is so simple and easy. One more thing I will include here, that is, if let's say the number of protons and number of neutrons in any case, the number of protons and number of neutrons in any case are even, then you don't need to do this much thing. You just directly can write the answer for spin and parity part. Let's say I am saying 6, x is something here, 12. What is the number of protons here? 6. Okay, what are the number of protons? 6, which is even. What about the number of neutrons? They will be 12 minus 6, which means again what? 6. These are even. Clear? Now, in this case, neither number of neutrons nor number of protons will contribute for the J or P. That means spin parity, even if they have asked, or angular momentum and parity for the ground state they have asked, you can directly say it's 0 positive. You don't need to work on anything. You don't need to write the sequence. When it is even case, directly write the answer. Also, to check out the complete process for the odd case and anything like that, you can check the sessions I have conducted for nuclear and elementary particle physics. For the ground state, okay, spin parity or the angular momentum and parity part, you will be able to know about it there. Okay, because then complete discussion we have considered. So I hope right now it will be clear to all of you. Is that okay and clear? Psycho, we are going to have that session now after this class at 11:30. Okay, we will have our next session on Monday and Tuesday after this one. Also guys, in Revise India series, the session we are going to have today, that will be the session before your exam, the only session it's gonna be in the Revise India series, which I am going to conduct today at 1 o'clock. In the description of this video, there is gonna be like a link. You can check it in the description. Okay, there will be a link. If you are even going to check it out right now, it is mentioned upcoming free classes. When you will click on that, you will get a page where Revised India series will be written and day 13, which is today's session. But even if you are someone who has missed the rest of the day's sessions, you can even check it out. Recordings will be available there. So in the description, the link is there for the free classes. Check it out. At 1 o'clock after this class, we are going to do the discussion of atomic and thermodynamics, both atomic and molecular physics and thermodynamics in the Revised India series. That will be one of the important sessions too. Don't miss it. Okay, and the way how you can join it, it's quite easy. Just in the description box there is a link. Okay, so from there you can check it out. And day means just the date. Okay, it's similar to date. So like today is 13th November, so day 13. If we had the session on day 3, that means 3rd November, so it will be mentioned day 3. Don't worry about it that you have missed any of the class. No, it's only about the date. It is mentioned like the day. Done? Okay, let's continue and let me just give you the next one. Abhishek, you can apply that one, but one more concept I have considered when I have discussed this topic, because with this particular rule, sometimes you may not get the right answer. So the rule I have explained, okay, just check it out, the previous classes I have conducted on any nuclear and elementary particle physics session I have conducted. There I have talked about it. You will get the exact idea about the formula and everything. So it's gonna be more easy as well as important, and will always give you the right answer. Done. Akash, some changes will be there in that case for the excited state part. Done. Let's consider the next question, guys. I'm just going to give you the next question now. Are you all ready for the next one? Done? Yes, Ramesh? Yeah. Series trick is like either just consider it sequence wise like this. If you will series, just observe the series, or you will write it in this way. So firstly S will be there, S half, okay, then P, it's gonna be half, and P 3/2. So you will observe the greater one is gonna be at this particular place and the smaller one is gonna be here. So in this way, if you will keep on observing, the series will be easy for you to memorize. The another thing is, instead of doing or considering it in this way, do one thing, make the complete structure first for all the terms present in that series, and then prepare it in this manner, SPP. So what you can do, you can form a statement with SPP. So you can just make any statement. The alphabets of the words you are considering in that statement should be starting from S first, then P, then P. Okay, so in this way, write for the further terms too. It will be easy, and make the pairs of 3 terms. So in this way, and you already know, like I have told you, if half is first, half is here. No, half will not be here. It's gonna be the greater one. It's opposite. 3/2 here and 1/2 here. So that means the larger value will be present first and the smaller value will be present later on. So it's gonna be P 3/2 and P 1/2. It's opposite. Okay, that's how we are just talking about it. It's not a smaller one first and the larger one later on. No. So make this complete sequence, and then this is how you can consider this part. Okay, the 3 terms pair you can consider. It will make it easy for you to memorize. Next question. Right, Vasudevan, that's correct. That's correct. Mahipal has mentioned a trick, guys, so you can consider that trick to memorize it. Clear? It will be easy again. Now let's consider the next question, and that's again gonna be from the one of the most important concepts in the topics. The first excited state of the rotational spectrum. The first excited state of the rotational spectrum of the nucleus That is again uranium given here. 92, uranium 238 basically. 238, this is it. Has an energy has an energy 45 above the ground state the energy of the second excited state is, very important concept based question, the energy of the second excited state is, okay. Options are, you can start solving it, 150, 120, 90, 60. 150, 120, 90 and 60. Try it now and let me know once you will get it done. Very good, Mahipal. We'll talk about it. The sequence, like, you have to consider in the same way, but we will talk about it like what exactly is the value you have to consider. That's very good, Abhishek. Very good, Karthik. Very good, Nisha. Very good, Kaku. That's good. Let's wait for everybody's reply, and then I'm just going to tell you about the sequence and like the steps you have to take to solve this question. Okay, try it first, then I'm going to let you know about it. Very good, Subramanyam. Very good, Neha. Very good, Monalisa. Very good, Neetu. Very good, Radhika. Very good, Ajay. That's very good, everyone. Very good, Anjali. Okay, so basically guys, the right answer is option A. How you will get it? Let's talk about this one now. Clear? So guys, if I'm going to talk about the process or the steps you have to take to get the answer, the first thing you need to know the possible J values. Okay, in this case, in this spectrum, that's gonna be 0 positive, okay, 0 positive, 2 positive, even parity, even J value. Okay, corresponding to that you can get the transition done in this case. So 0 positive, 2 positive, 4 positive, 6 positive, like that. So these are the values of JP, okay, which we are mentioning here. These are the allowed values. Now the point is, the first excited state of the rotational spectrum of the nucleus, this one, has an energy 45 kiloelectron volts above the ground state. Okay, the point is they have given us the rotational spectrum of the nucleus and its corresponding energy, which means the rotational energy is given to us. Now the point is, what is this rotational energy? So guys, the rotational energy is E rotational is equal to h cut square upon 2I j into j plus 1. They have mentioned this thing here, that the energy is given for the first excited state. If I'm saying the ground is 0 positive, then 2 positive, then 4, then 6. This is the first excited state. That means the value of J is 2 here. So when you are going to consider J is equal to 2 here, what you can say? You can write the energy 45. Okay, write it here. 45 is equal to h cut square upon 2I. J into J plus 1 means what? 2 into 2 into 2 plus 1, which means 3 into 2, that is 6. You have got this. From here you are getting the value of h cut square upon 2I, which will be what? It's gonna be 45 upon 6. Okay, this is the constant value you have got for the same nucleus, that is uranium. If I'm going to read the question further, it is given the energy of the second excited state. That's what you need to find. That means in the same way, what you need to do, since you got the value of the constant now, which is h cut square upon 2I, you will just put it the same value there, and E rotational for this, that is the second excited state, which means the J value is 4. So h cut square upon 2I, J into J plus 1. Again, what you will have to do, h cut square upon 2I, just put it 45 upon 6. And the value of J now for the second excited state is 4. 4 into 5, okay? So just consider it here. Then you can simplify it further. 3 2s are 6, 3 1s are 3, and 5. 2 2s are 4, okay? And then 30 into 5, 150. That's gonna be your right answer. This is gonna be the answer. Okay, and the steps you have to consider, they are quite easy, simple, basic, and this formula, rotational energy formula, is very important one. But main thing you need to consider after knowing about the formula is that what is the value of Jp, which is like the possible values of Jp. Clear? They are gonna be very important ones. Okay, and now if you got this question, it's gonna be easy for you to solve any such type of question anytime. Done? Clear? Done. Yasir, today the questions we have discussed, all of them were from the previous year's CSIR net physics exam. Guys, those who are attending this session from the starting and those who have solved all these questions, they all were from the previous years, okay, and were from like very important concepts, from where there are great chances that you can expect the questions in the exam. Wafia, it's same. The JP values are same for this type of spectra. Okay, they are always going to be even value of J and even parity. So 0 positive, 2 positive, 4 positive, this will remain fixed. This is the fixed thing. This is the formula. Okay, these two are just, you can consider the concepts involved in any such kind of question which you have to consider from your side. Clear? Thank you so much everyone for watching this video till the end, for attending this session, and at 1 o'clock we are going to have atomic and molecular physics and thermodynamics session. You can join it at 1 o'clock today with the link given in the description. Directly from there you can check it out. Day 13 session will be today's live class, okay, the spatial class basically, okay. And one more thing, that guys, after today we will have our next YouTube sessions here on Unacademy Live CSIR UGC Net, okay, on Monday and Tuesday before your exam. 2 sessions are gonna be there, 2 more sessions which will be at this time before your exam, only 2 more sessions, okay. So don't miss them, attend those sessions too on Monday and Tuesday 11:30 AM. But today after this class, the spatial class we are going to have, okay, in the Revise India series at 1 o'clock. After this class at 1 o'clock in the afternoon, clear, you can join that session too. It's gonna be the important one. If we are going to talk about the next point, guys, as I have told you in the starting about the Unacademy Plus subscription and the important courses which are going on, and the most important courses like are gonna be there soon. New courses are going to start for the GATE physics exam as well as for the next CSIR net exam. So if anybody is here who want to prepare with the Unacademy Plus courses and with the guidance of all the top educators we are having on Unacademy Plus for your upcoming exam preparation, then you can take the Unacademy Plus subscription, okay. And by using and by applying this referral code, that is Anjali Arora, as it is mentioned here, by using and by applying this referral code, you will get the 10% discount in the total Unacademy Plus subscription amount, okay. And guys, even if you are targeting or you are considering to prepare for the GATE physics exam, you can take the subscription as soon the GATE physics exam courses are going to start. After your CSIR net exam, those courses are going to start, and even there are going to be many important courses going on for your next exam as well, okay, like the strategy course and many other courses which will help you to get familiar with the exam pattern, to know about many important things. So even at this point of time, anybody is there who want to take the subscription and who want to start the preparation for the next exam, or even for this one, there are quick revision courses going on, the practice courses going on. So if you think you still want to just take out those sessions, you want to attend those sessions, you can take the subscription. It will be helpful for you. And whenever you are going to take the subscription, you can use and apply the referral code, that is Anjali Arora. As it is mentioned here, no space in between, spelling should be same. That's how you need to write it and apply it. Okay. And one more thing, guys, even let's say if anybody is going to take the subscription right now and there is some course which is already going on and some of the classes of that course has already been conducted, in that case you will get the recordings of the sessions, and that's how you will be able to cover up that part or that portion too which you have missed, okay, or which has already been conducted in that particular course. One more thing, guys, that there is gonna be championship mock test going on Sunday. Okay, even if you want to attend those championship mock tests, you can attend them on Sunday, and on Monday or in the upcoming days in the same week, we are going to have their analysis sessions too. So they are going to be important ones as well. Okay, and one more thing, Revise India series session, which is going to be today at 1 o'clock after this class. In the description of this video, there is link. From there, you can join the day 13 session, or even if you have missed the previous classes, you can attend or you can watch them as well. Thank you so much everyone for joining this session. Thank you. I hope it was helpful for you. Next class on Monday and on Tuesday at 11:30 a.m. Okay, here on Unacademy Live CSIR UGC Net, which is Unacademy's live YouTube channel. Also, guys, one more thing. Revise India series session today at 1 o'clock. That's gonna be the last one before your exam, which I'm going to conduct. Okay, so yeah, don't miss the session. Yasir, on Monday, Tuesday at 11:30. Now, before your exam, 2 more sessions are there here on Unacademy Live CSIR UGC Net, which is Unacademy's live YouTube channel. Then, thank you so much, everyone. Thank you.